All right, as mentioned in the last video, we now introduce the villain of economics, which is the monopolist, and see why monopolies are bad. So let's start by talking about the assumptions of a monopoly. So again, in perfect competition, we had so many people competing with each other that everyone was a price taker. We had an atomistic market structure, and we had free market entry and exit. A monopolist, on the other hand, is a price maker. There is only one supplier, and there is no free market entry. And of course, the causes of market entry barriers could be many, like governmental protection. Sometimes there's something that we call a natural monopoly. That's the case whenever a certain industry like mining is associated with high fixed cost, and there is naturally no easy competition possible. But also collusion, like several firms, they might collude and act as if they are one. So those are like the main causes of market entry barriers. But let's just move a little bit to how a monopolist maximizes profits. So while the demand function for a perfectly competitive firm is essentially a horizontal line that represents the market equilibrium price, the monopolist can manipulate the market price depending on the quantity supplied. So the perfectly competitive firm can sell as much as it wants to at the market equilibrium price, and whatever quantity it supplies has no effect on the market equilibrium price. So that is the perfectly competitive firm. But for the monopolist, on the other hand, the price is a function of the quantity she supplies. So that is the price that the monopolist faces is essentially given by the demand function. And whatever the monopolist chooses in the quantity will then determine the price. So the difference between the total revenue in a perfectly competitive firm was that in a perfectly competitive firm, PC, perfectly competitive firm, actually PCF, the total revenue was given by a given price times the quantity. But a monopolist doesn't have to accept the price. A monopolist is a price maker. So the monopolist has a total revenue function where the price is actually a function of the quantity times Q. So if we just take a simple example, what that means is so let's say we have a demand function, an inverse demand function, which is, I don't know, let's say 8 minus Q. So then, if a monopolist chooses a price of 4, if the monopolist chooses a quantity of 4, the monopolist knows that it can get a price of 4. But likewise, if the monopolist puts only 6 units into the shelves, the monopolist knows that it can get a price of 2. And if the monopolist only puts 2 units into the shelves, it can get a price of 6. So the price that the monopolist can fetch is a function of the quantity, and then the total revenue is whatever the price of that associated with that quantity is times the quantity. So if we generally have an inverse demand function, which we write as P is a function of Q, A minus BQ. So in this case, with an example, here we had P equals 8 minus Q. So in this case, A would be 8, B would be -1. So, but a monopolist also wants to maximize profit, and profit maximization requires that the marginal revenue equals marginal cost. Well, in a perfectly competitive firm, the profit maximizing condition was marginal revenue equals marginal cost, but the marginal revenue was the price determined by the market. It has to be equal to marginal cost. Well, in a monopolist, the marginal revenue is not the fixed price, but the marginal revenue is still the first derivative of the total revenue. But for a monopolist, the total revenue is the price as a function of Q times Q. And then if we say, for example, if we generalize the inverse demand function as A minus BQ, that is P times Q, what do we get? And we multiply through, and we get A times Q minus BQ squared. So that is the total revenue function. And the marginal revenue function is the first derivative of this. So then we do the change in total revenue over dq. That is then A minus 2BQ. So the point here is that the marginal revenue function for a monopolist is twice as steep as the demand function, because the demand function is 8 minus BQ, and you see the marginal revenue function is A minus 2BQ. So that means for the monopolist, the profit maximizing condition is that A minus 2BQ, which is the marginal revenue, has to be equal to the marginal cost. So now let's take a look at what that means by going through an example. So we have an inverse demand function, and this inverse demand function is P 8 minus Q. So the monopolist knows, okay, if I supply 1, I can fetch a price of 7, my total revenue is 7. And if I have a price of 2, I can fetch a price of 6, and 2 times 6 gives me a total revenue of 12. If I supply 3, I can fetch a price of 5, my total revenue is 15. And if I supply 4, I can fetch a price of 4, total revenue is 16. Then total revenue goes down again, because if the monopolist supplied 5, the price would be only 3. 5 times 3 is 15. At the quantity of 6, price is 2. 6 times 2 is a total revenue of 12, and so on. But so the total revenue function for the monopolist is the price, which is given by the formula 8 minus Q times Q, or 8Q minus Q squared. And the marginal revenue, which is the first derivative of this one, 8Q derived with respect to Q is 8 minus Q squared, derived is 2Q. So that's the marginal revenue. So the marginal revenue is twice as steep as the demand function. But the profit maximizing condition is still the same, which is that as long as the marginal revenue is greater than the marginal cost, the monopolist will provide another extra unit. And the profit maximizing quantity is at 3. and the monopolist will charge a price of 5. That is the monopoly price, and the monopoly quantity is 3. So what happens now is, if we do some welfare analysis and we compare it to, for example, perfect competition, we would say, well, in perfect competition, the optimum quantity would be price equals marginal cost, and everyone is operating at the minimum of ATC. So this green dot would be what would happen under perfect competition. And we see in this case we would have allocation efficiency, price equals marginal cost. Well, we don't have allocation efficiency because, if you remember, the supply function is a lineup of consumers according to their willingness to sell. So, but now there are some consumers left whose willingness to pay is actually greater than what it would cost the firm to supply them. But this is not what the monopolist wants. The monopolist wants to supply a lower quantity and charge a higher price and leave some people unserved. And that is, of course, what creates the deadweight loss. So here we would have a deadweight loss, which would be roughly this area here. That is a deadweight loss that would result in welfare if the market were perfectly competitive. So it's a little bit complicated to operate with a marginal cost function, which is not a straight line. So let's do another example where we can compare the monopoly with a perfectly competitive market more easily, and we just assume in the next example a horizontal marginal cost line. So that is just to keep things easier. So again, the inverse demand function is still P equals 8 minus Q. And the monopolist has the total revenue function. So total revenue, again, would be price, which is 8 minus Q times Q, which we said is 8Q minus Q squared. And then the marginal revenue is twice as steep, 8 minus 2Q. So that's that green line. And for simplicity, the marginal cost is a straight line. So now we see that the monopolist will choose a quantity of 3 and charge a price of 5. Okay, so in the perfect competition, on the other hand, consumers will be served as long as the consumer's willingness to pay is greater than the extra cost of production. So under perfect competition, a price of 2 would prevail and a total quantity of 6 would be turned over. Consumer surplus would then be the entire triangle above the marginal cost function, which is the blue, the yellow, and the orange area, which is 6 times 6 over 2, which is 18. There is no producer surplus. All the welfare goes to the consumers, and total welfare is 18. The deadweight loss is 0. Okay, so the producers, they don't like perfect competition. Producers like monopolies, and we can see that. So if, let's say, that is not a perfectly competitive firm, but a monopolist, the monopolist would prefer to charge a price of 5 and only supply 3. So then the monopoly would get a rent of that yellow area, which is 9. That's producer surplus, or another word for it would be the monopoly rent. Consumer surplus would be only 4.5, that blue triangle on top, which is a reduction of 13.5. Well, the producer surplus, it would be a plus of 9, and welfare is only 13.5, which is the deadweight loss, which reflects a deadweight loss of 4.5. So in other words, by switching from a perfectly competitive market to a monopoly, the monopolist is made better off by 9, that's the monopoly rent, but at the same time consumers are made worse off by 13.5, which results in a deadweight loss of 4.5. So that is why we don't like monopolies, because a monopoly creates a deadweight loss, and we definitely have allocation efficiency. So what we know for sure is monopoly is allocation inefficient. Allocation inefficient because the resulting price of 5 is greater than the marginal cost of 2, which suggests there are people whose willingness to pay, that there are some people whose willingness to pay is greater than what it costs to serve them, but the monopolist doesn't care for them. But what about distributional efficiency? So we can't really tell whether a monopolist will be producing with production efficiency. So let me maybe try to illustrate this quickly here. So we said a monopolist has a demand function. That's a demand function, and faces a marginal revenue function, which is twice as steep. So it cuts maybe here. That's the marginal revenue function. And we have some kind of a marginal cost function. And we have now here the profit maximizing quantity, and here we have the monopoly price. P star monopoly. So it could be, so we don't know, it could be that for whatever strange reason, that at this point actually the average total cost is here, and in this case it could be that the monopolist produces production efficiently. Unless we know anything about fixed cost, we can't tell. There's probably good reason to assume that this is not the case, and the situation may well be like this, so that they are not producing efficiently. Could be either one, we don't know. The only thing we know for sure is that a monopolist produces allocation inefficiently but the monopolist may produce efficiently in terms of production or not. We don't know. The only thing we know for sure is there's a deadweight loss, price is greater than marginal cost, and there will be allocation inefficiency. Production efficiency could be or could not be, we don't know. Okay, so that is the monopoly, and there's one more market that we want to talk about, and that market is known as monopolistic competition, but let's do that in the next video.